The final feature I want to create is the screw-in base, which is tapered and has a helical thread. To start this feature, I'll create an offset plane 0.1 inches below the top plane. I'll draw a circle on the new plane centered on the origin. Next, I'll extrude the circle in two directions. In direction 1, I'll use the up to next end condition with a 3-degree draft using the draft outward option. In direction 2, I'll use the blind end condition and a depth of a 1/2 inch with a 3-degree draft. The draft should be inward so that the feature tapers smoothly from end to end. I'll click OK to complete the extrude feature. To complete the general shape of the base, I'll add a chamfer on the bottom edge using the distance setting and values of 0.35 and 0.125. Now, part of the reason to start the extrusion from an offset plane is to reuse the sketch for the helix. To do this, I select the circle sketch from the Feature Manager and use Convert Entities to create a matched circle. Then click the Helix Toolbar button. Create the helix using pitch and revolution with a constant pitch of 0.125 inches, 4 revolutions, and a start angle of 90 degrees turning clockwise. Also, set the taper to 3 degrees to match the extrusion, tapering inward. The thread on the bottom end of the screw-in mount will simply run off the end of the mount, but on the top end, it must be terminated somehow. There are many ways to terminate the ends of a thread, and what follows is simply one approach. I want to draw a 3D spline tangent to the end of the helix. This enables me to control how the thread sweep leads into the part. There is a problem with this approach, however. A 3D spline cannot be made tangent to a helix. To work around this limitation, I simply use Convert Entities while in a 3D sketch to convert the helix into a 3D sketch spline. Now I can add a short spline to the end of the converted helix. And the tangent relation is available. I'll manually drag the spline to control how the thread will lead into the part. When the spline looks good, I'll exit the 3D sketch. Since this feature will be a swept cut, the next sketch I need to draw is the cross-section or profile of the sweep. It's best if the profile is on a plane perpendicular to the path. To ensure this, I use the Plane tool to create a reference plane perpendicular to the free end of the sketched 3D spline. On this new plane, I then sketch the sweep profile. Notice that construction geometry is used to position the profile. and that the profile will extend slightly past the solid body when it's swept. This will prevent errors that might arise due to zero-thickness geometry. It's also important to note that other dimensions may be used to control the width of the cut. Sweeps in SolidWorks are not allowed to intersect themselves, so if this cut is wider than the 0.125-inch pitch of the helix, it will run into itself during creation. So if you need to create a swept feature that intersects itself, you will need to create the feature in multiple pieces which intersect one another, but any single sweep cannot intersect itself. This is true for solid and surface features. As finishing touches, I'll place a small fillet at the root of the cut thread. And another around the base of the mount. And this completes the fluorescent light bulb.